To use the lever as a first class lever, we want to have a load on one side of the fulcrum, and we want to apply the effort to balance the load on the other side of the fulcrum. I'm hanging the 2 kilogram mass from the lever at 20 centimeters from the fulcrum, and I'm applying my effort using a spring scale at the 40 centimeter mark from the fulcrum. So this distance is 40 centimeters, this distance is 20 centimeters. To use the spring scale, I hang the spring scale now from the hook, and I pull down on the bottom part of it, and then we can read the force required to balance the load. And so in this case, the force is approximately 10 newtons. Now, you'll notice that I am adding the mass of my scale to this side, and as long as I use fairly heavy masses, the error that introduces is fairly minimal. I can also use the spring scale upside down, in which case I am not I'm not adding the weight or the mass of the scale to the system. I'm only adding the mass of the hook and the metal strip that is attached to the spring. So this gives me about 10 newtons. So twice the distance, half the effort is required to balance the load. We can then move it out further to 30 centimeters from the edge, and in this case I can't pull it down quite far enough, so I need to raise my lever, and I can do that easily with the clamp, and now I can pull it down again. In this case, my effort required to balance the load is approximately 14.5 newtons. So this is a first class lever. We can take loads at different distances from the fulcrum. We can also place the effort at different distances from the fulcrum. And students can then make a chart in which they set up the load distance and the load, the effort distance, and the effort.